we are going to verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. So here's the difference. In this case, up here, in these cases up here, we just had to say, oh, the intermediate value theorem applied, and here's why. It's continuous, it's between the two values, and again, this goes back to these two things that we highlighted here. So let's look at this one. I want to, first of all, talk about continuity. Is this function continuous on this interval? Yes. Okay, this is a polynomial function. Polynomial functions are continuous everywhere. Negative infinity to infinity, excuse me. So we're good. We have continuity. Number two is the y value that we are looking for in between the y values that are generated from the endpoints of the interval. And I don't know that. So let's grab a pen and let's figure it out. I'm going to figure out what f of 0 is. There's the 0. And I can just do this one in my head. I get -2. And then f of 3. And when I plug in that, I'm going to save you the trouble. You know how to do math. It's 19. And I am looking to see if 4 is between -2 and 19. It is a wet spot on my paper right there. My hands were wet when I started the video. You didn't need to know all that, did you? So -4 is going to be between... 4 is going to be between -2 and 19. So therefore, we have betweenness. We have met the two conditions, and we have a spot on the paper that you can't unsee. And so we are going to write it down. Let's see. F of x is continuous on the interval from 0 to 3. It's continuous everywhere. And f of 0... f of 3, okay? And we're going to say that 4 is between them, and 4 is truly between them in that order. I put less than or equal to for both of those, but it doesn't have to be equal. Therefore, the intermediate value theorem applies, and we're also going to find the C value. We want to find out what that X value is, where that is true. So, let's do it. I'm going to, first of all, say this happens, and therefore, oh, by the way, new symbol that you never knew before. Instead of writing the word therefore, you can do this. It's a mathematical symbol for therefore. That's what it's there for. Therefore, the intermediate value theorem applies, and just in case you're looking back at your notes later, and what is this Illuminati triple dot thing? This just means therefore. That's just the way we abbreviate it. Okay, but now we're also going to find the C value. We need to find out exactly where this happens. So we want to know if f of C equaled 4, what would C be? So C cubed minus C squared plus C minus 2 equals 4. So here's our function with C plugged in, and we're going to make it equal 4. And yeah, you could solve that by hand if you're fantastically magical, but we are not. And therefore, we will graph it. So let's graph. And of course, we're back to using an x instead. X to the third minus x squared plus x minus 2, and we want this to equal 4. We could move the 4 over to the other side, and we would have minus 6 equals 0, and we'd find an x-intercept. But either way, it's going to work. So, graph. There we go. Now, we might have more than one x-intercept in some cases. I'm sorry, more than one point of intersection in some cases. In this case, we only have this one point. If we had more than one point of intersection, what would we do? Well, we would list all of the points of intersection as long as they fall in this interval. And we are looking for where it falls in this interval from 0 to 3, and that's the only one in this case. But we will find that point of intersection. First curve, enter. Second curve, enter. Guess, just enter. And the answer is just 2. So, C equals 2. All right, let's tackle the next one. First of all, we need to have continuity. Is this function continuous? Yes and no. It is continuous on this interval. It's not continuous at 1, but the number 1, the x value of 1, is not in this interval. So we're okay. So we can say, now that this spot is dried, f of x is continuous on the interval from 5/2, which of course is 2.5, to 4. And let's start verifying a few other little things. We're looking for betweenness. is 6 in between the outputs of these two inputs? Let's find out. So f of 5/2 is equal to something, and f of 4 is equal to something. I don't know what that something is, but let's use a calculator for this one. We could do it without a calculator, but for the moment, I choose not to. So in a situation like this, I highly recommend that you put parentheses around the numerator and denominator, otherwise you're going to get it wrong. So x squared plus x divided by x minus 1. We need to group those separately. And I think we can go to the table. Delete other old things. So I need 5/2, and I also need 4. So this is 5.8333333. There we go. That's good to know. 5.833333. And then when we plug in a 4, we get 6.6 repeating. Now, just fair warning here. Sometimes this value is lower than this value if the function is supposedly decreasing, at least for some portion of it, on that interval. And therefore, when we write the betweenness, we would put this one first if this number is lower than that one. But we'll see it when it comes. So therefore, or not therefore, as in like triple dot, but we can write this. There we go. Therefore, the IVT applies. Oh, we'll put that on the same row. Applies. And now we're going to find the actual C value. So f of C is equal to, well, C squared plus C over C minus 1, and that should equal 6. And we're going to figure out what that is. All right. We're going to graph that, and we're going to graph 6 and find out where they meet. There we go. There it is. And I say there it is. Actually, there they are. There might be more than one of them. So we are finding everywhere that this function, the blue function, meets with the red function. And it actually, if you look very closely, you'll see that it happens in 2 places. If it's not obvious, let's adjust this a little bit. We need to go from 2.5 to 4. Let's do that. So x is 2.5 to 4. And what y value should we pick? I don't know, but let's just pick something that, let the calculator pick it. Automatically adjust it. So zoom 0, zoom fit. It's a handy little thing to do. Okay. So there were 2 points of intersection, but only one of them took place in the given interval, from 2.5 to 4. So let's find that point of intersection. It looks to be that exact dot, which I believe is 3. Intersect, enter on the first curve, enter on the second curve, enter on guess, and our C value would be